7.6, which one?
105.
All right, cool. So there's two things from 7.6 I still need to do. There's the word problems from 7.6. And then there's the using the calculator kind of problems from 7.6. So we're going to get into the calculator. That's why I brought my calculator cooler. You know, bring us to the beach in case you have to do math at the beach. Calculator cooler, dude, a calculator. You're the most popular person on the beach. All right. So let's get into this. This is 7.6 word problems. I think I was just so excited to get into chapter 8, I just kind of forgot to do this. All right, so these word problems involve a little bit more than your basic word problems, but the nice they kind of fall into the same pattern every time. Can somebody help me out? What is the equation that relates distance, rate, and time? I love it. So I don't know, are those my students saying that? Because that's what I tell my students. I don't know if other people say. So distance equals rate times time. Dirt. Rockets. And we know this. You know this. If you're going 50 miles an hour and you travel for 2 hours, how far did you go? 100 miles. 50 miles an hour times 2 hours. Rate times time is distance. I like it. In fact, what units does rate have? What units is rate? Rate, of course, we call it what when we're going in a car? We call it
Miles per hour.
speed. It's miles per hour. And if you solve for rate, how do you get R by itself? Divide by T. So rate is D over T, for example. Distance, miles, normally, per hour. Hey, shit, it matches with the units. Oh my God. All right, cool. So when they write the MPH, it kind of hides the fact that it is a fraction. It's not oomph, it's miles over hours. I like it. Cool. So how does this relate to any damn thing? Well, I can see a problem like this. Let's start off with one that's not too freaky. Blah, blah, blah. All right. Well, okay. So here's a classic kind of problem, an airplane problem. I'm working my way back to 105 because 105's got a little bit of weirdness in it with the units, right? So say a plane, if it flies into the wind. Because if anybody ever done like an east to west, like I go for Christmas, I go back home to Virginia, and then I come back, and one way is always longer than the other way, and one reason for that is one direction you're going with the jet stream, the other one you're going against it, so of course you're going to be going slower coming back, right? So flying into the wind, it can go 380 miles, and the same time that with the wind, it goes 420 miles. So it takes the same amount of time into the wind, it goes 380 miles, and the same time it takes to go 420 miles with the wind. Now why does that make sense? Because when it's going with the wind, it's going faster. The wind is pushing it, right? If anybody ever kayaked or something, you're going with the current, you're like, yeah, right? So like I go off La Jolla Shores, and when you're coming into the beach, you're like, yeah, look at me go, sweet. And when you're trying to get out, you're like, oh, shit, man, what the hell? We all know this to be true. So here's one way you can do this. And this is a suggestion, but if you have a different way to do this, you can do it. I just like to accumulate all my stuff together. So I've got two situations. So I'm flying into the wind. So against the wind and with the wind. And the question really is, what's the question, Jeff? The wind speed is 10 miles an hour. How fast is the plane going? Okay. So one nice thing about these problems is the question they ask is going to directly relate to what the variable is going to be. So in this case, what will my variable represent? What do I need to assign a variable to? What is it that I don't know? I know the wind speed.
Plane speed?
Plane speed. Gotcha. So the plane speed, we're going to let this be, sure, x. I like it. All right, let me stop there for a second. So most of these kind of problems, you just have to look at the question and go, oh, that's my variable. What's the speed of the car? Well, the car speed is x. All right, sweet. Or sometimes you have a slower car and a faster car, right? So one could be x and the other one's x plus 7 because it's going 7 miles an hour faster, trying to catch it. So, tell me this. If I'm going against the wind, how fast will my plane actually be moving? If I'm flying into this wind, how fast will it actually be moving? You can do this. X minus 10. 10 mile an hour less than what it actually is trying to do, right? Have you ever, I keep going back to kayaking because you ever seen if you're going against the current, you can actually paddle at the right speed that you just stay in one place? So if this plane was trying to go 10 mile an hour, it would be basically just hovering. And, well, shit. We're never going to get there. No? Yes? You understand that? Maybe? Okay. So what do I put where? Against the wind, based on what we just said. Where's that go? X minus 10. Rate. So the speed of the plane, the rate at which it's traveling is x minus 10. So what's it going to be with the wind? X plus 10. Kick ass. So we see this kind of problem a lot. Boats and current. It goes upstream and downstream. It's just like against the wind, with the wind. It's the same exact thing. So it'd be the same kind of setup. All right. And the beautiful thing is, what goes here? 380. I mean, it tells me 380 miles. So they got to tell you something. Then they got to tell you a relationship so I can write variable expression somewhere. And my problem now, so what goes here? 420. So now it's what are these? So whenever you get this chart filled up to where you have one blank spot left in both rows, then you use the formula. Distance is rate times time. So what's time? If d is rt, what's time equal to? What do you do to get t by itself? Divide by r. So what's it going to be here? Distance divided by rate. So what do I put there?
380 over x minus 10.
Let me stop there for a second. This is where you guys have to realize that math, we kind of care if we don't know something, but math does not give a shit. Math doesn't care. So for example, real quick, stay with me. If the plane went 380 miles and it was going 190 mile an hour. It's kind of slow for a plane, but a little Cessna, a little something. If it went 380 miles and it was going 190 mile an hour, this the distance is the rate. How long did it take it to do that?
Two hours.
Yes, it goes 380 miles. It's going 190 miles per hour. So every hour it goes 190 miles. So how many hours would it take to go 380? 2 hours. So what do? That divided by that gives me time. That divided by that gives me time. So if x were 200, do you see how that would be that situation there? Alright, so that's not coming out of nowhere. That's just me giving myself a number so I can see what's going on. So this is where I think students don't quite get it, and I can't blame you that much. But I know, if I know a distance and I know a rate, I divide them to get the time. That is just it. That is it. That is what you do. That is what everybody on the earth would do. We just happen to have rate is unknown. But math doesn't give a shit. It says take whatever distance is and divide it by rate. And we kind of go, I don't know. Just write it. There you go. Now, so what goes here? Now, what's the relationship between the times? Who remembers? I don't think I wrote it up there, but what did I say? In the same amount of time. So what's the equation I can write? This time has to equal that time. So that's how these problems are almost always going to work. You can fill in 4 of the boxes. The last 2 you filled in based on the formula. And then you say, how are these related? Was the total times 7? So this plus this is 7. You'll see those kind of problems. Right? Or maybe these will be the things that you fill in, and this is the total distance of 500. So the distance plus distance equal 500. It doesn't matter which boxes are left unfilled. You just look and see how they're related. So then it would say 3 eta over x minus 10 equal 420 over x plus 10. Oh shit, there went everything. Sorry, Randy, you alright? We're not laughing at you, man. Alright. So how do I solve that? This is the one place you can do what?
Cross multiply.
Cross multiply, I love it. That should be easy to finish. So, I don't know, does anybody notice that you could actually divide both sides and reduce these numbers? If you don't, it doesn't really matter that much yet.
So on 7.6, I can ask the question afterwards, when you're done with that one.
Okay, yes, that would work better. So then, if I cross multiply, I get 380x plus, good, 3,800 equals 420x minus 4,000. And that's, you gotta love that. The numbers are a little bit big, but who cares? That's easy. Easy, right? Subtract that, add that, divide, you're done. You guys okay with that? Semi okay? Have you guys ever seen this? Some of you guys must have seen this before, right? The chart method? No? Do you understand it? I like this because it's an easy way to organize what you know and what you don't know. And then it helps you put together the equation. If you don't want to use this, you don't have to. If you can get there, that's awesome. Alright. So let's take a back step here. Let's go back to the one you asked me about. I'll get this to a point, and then I want you guys to finish it out because it's actual homegrown. So this is 105. There's a 6-mile bike race. And the winner finished 2 minutes ahead of the second place person, or the teammate. All right, let me stop there for a minute. The winner finished 2 minutes ahead. Is everything cool? Are you okay? Okay. 6-mile bike race. The winner finished 2 minutes ahead, and the winner traveled 2 miles an hour faster. So it kind of makes sense that they came in ahead if they're going faster. That kind of makes sense. Thank God. So then the question is, find the average speed of each racer. Now, I don't know if you were listening earlier, but when I was talking, I said the main issue with this problem to begin with is the units. You always got to look out for units. If you haven't taken the SAT yet, for example, they love to give you a problem where this side is in feet and this side is in inches. Ha ha. You know, so come on. It's crap. You just got to realize that. So here, where are my units kind of let me down? You guys see? Can you see? This is miles per hour, and this is... Holy shit. So, who can tell me 2 minutes equals how many hours? And I love it when somebody says, 2 minutes ain't even an hour. Okay, then it's a fraction, ain't it? That's what fractions exist. When you don't have a full thing, you got fractions.
2 over 60.
2 out of 60, right? What makes a full hour? 60 minutes. Well, how many out of 60 do we have? 2. So it's 2 out of 60 hours. I love it. 2 out of 60, 2/60ths of an hour. Let me say it like that. Not 2 out of 60 hours, but 2 over 60 hours. Or you can write it as 1/30th of an hour. I love it. So it would be strange to say, it's going to take me about 1/30th of an hour to do. But you could, if you wanted to. That's 2 minutes. Yes, ma'am.
It doesn't say how many races there are. Is that irrelevant?
Oh, it says the winner finished 2 minutes ahead of a teammate. So it only references 2 racers. So it doesn't really matter how many there were total, because we're only concerned with these 2. These are the only 2 that we have a relationship between. Does that make sense? So it doesn't matter who else was there, how fast they were going, what they ate that morning for breakfast, any of that. So what are my variables going to be here? My variables have to represent what? What physical thing?
Distance.
You got one left.
Race.
Yes. Because the question is,
Average.
what's the average speed of each racer? That's what I don't know. So what's the average speed? Who's going to be just X, the winner or the teammate? It doesn't really. So the winner went 2 miles an hour faster than the teammate. So if we call the teammate what?
Slow.
Like maybe someone with less letters in it. 1 letter.
Yes.
X. So if we say the teammate went X mile an hour, how fast did the winner go?
X plus 2.
X plus 2. So even though we have a different way to set up the information than we did with the word problem sheet we did last time, it still follows the same steps. What are you going to call just X? Who is everything else? On this problem, what was just X? The plane speed. Well then, what are these things? Minus 10, plus 10, depending on if you're going in or with the wind, right? Who's just X? What are the other things in the file? Go from there. All right, so now we can set this up. Distance equals rate times time.
Isn't the winner of the race 2 minutes faster than the teammate? So it's X minus 2, isn't it? Or the
What's X? What's X represent physically?
The speed of the
Speed.
Yeah.
Speed. And this is time. I like it. So it's 2 miles an hour faster.
Yeah.
So the winner was going 2 miles an hour faster than the. Yeah, I like it.
I was thinking 2 minutes. Thank you.
I got you. All right. Maybe. And now you just got to fill in what you know. And there's going to be some blank boxes, and you're okay with that. There have to be blank boxes, in fact. So what can I fill in? What do I know for sure? What do I know? No question. The very first thing it tells me, it just tells me directly.
The race. Distance. 6 miles.
6 miles. It's a 6-mile bike race. So the winner went 6 miles, as long as they didn't cheat. And the teammate went 6 miles. We're assuming they didn't cut any corners. I love them saying, well, technically, they're swerving, so it's actually that's a good point, but no. All right. I don't know. So the most important thing to do to get from when I do an example problem is the idea of how to set it up. If there's something specific about this problem that gives you trouble, okay, but get the idea. What's my variable represent? What is it that they just tell me directly? Start filling in spots. It's kind of nice. So where do these go? The rate, because that's the speed. I like it. So the winner is X plus 2. And the teammate was X. I like it. So then what can I put here based on what I already have there? Well, this thing right here, I haven't used this 1/30th thing yet, have I? That's fine, because that's where the equation is going to come from. The equation is what tells me how these relate. One is 1/30th more than another, or less than another, depending on how you look at it. Okay, maybe. So, what do I put here?
6 over.
Good. Distance divided by rate is time. So I know that they went 6 in X plus 2 speed, and this guy went 6 miles using speed of X. So let me ask you this. You can look at it as either way, and sort of you brought this up a minute ago. So the winner was 2 minutes faster than the teammate. So however long it took the teammate to do it, it took the winner
2 minutes left.
2 minutes less. So however long it took the teammate to do it, it took the winner. Let me see. Let me give myself some room. Let's see if you guys put this. I just sort of gave it away. Well, let me say it like this. The winner speed, that time, was 2 minutes less than the teammate's time. Does that make sense? There's some different ways to say this. So whatever the teammate's time is, I take 2 away from it to make it the same as the winner's time. The winner took 2 minutes less than his teammate. I like it. Well, what does that look? Now that looks more like an equation we know how to work with, right? So how do I, just to get you guys thinking correctly here, I just start doing what?
We do the common denominator.
Yeah, exactly. Giving everybody whatever they're missing. I love it. So that's as far as I'll go with that. Now should be the relatively easy step. Normally it's getting to the equation that's gross.
Where did you get that name? That -2.
2 minutes ahead.
Okay.
Right, so it's however long the slower dude took, it took the winner 2 minutes less than that. Whatever his time. So if his time was 40 minutes, it would have taken this guy 38 minutes. 2 less than whatever it took the slower dude.
Okay.
Right? So you really got to take a second and think about it. How do I put this 2 minutes? I'm sorry, now one thing I just did, I'm silly. Does everybody understand what just happened?
Yeah.
This is minutes, and we just did the whole thing about making it into hours. So what should I put here?
1:30.
1/30th, I like it. I did the whole spiel and then said, screw it, don't worry about it. So they have to be, this is hours, this has got to be hours, 1/30th of an hour. I like it. So the LCD gets a little bit more disgusting, but at least your units are right. Okay. I like it. Yes, ma'am?
It was 108 on that section.
Oh, 108 is compared to this. This is a true word problem. Because it's not just plug and chug into an equation. Because you don't have an equation. You got to make your own equation. 108, they give you the equation. Do you see that? The equation is 30 over x. And then they say, what is it for x equal to 1? So just plug 1 in.
It was part A that was confusing.
Which one?
A. On
That part A, yeah. On 108? So, let's see.
I'm looking at the computers here, they weren't able to help me.
Really?
Yes.
Shit.
What problem? 108.
7-6? Okay, I'm concerned now. I must go.
Go pop in over there.
Just say, hey, I just need to talk to you for a minute. Do you know math? Let me see. They should have no trouble with this. I don't understand. Yeah, where could they possibly? I'm trying to figure out what they would have thought was going on.
Maybe
don't.
they did too much math in the day.
They were thinking too much, I guess. I don't know. So what's this represent? What does this represent? What does it tell you it represents? The braking speed, right? This is, well, the braking distance. I like it. So I can call this B of x if I wanted to, right? The braking distance of that. So part A just says, what's B of 1?
Oh, okay. So then I just plug in the 1.
And it tells you what units it's in, right?
Yeah.
X is so X is a neat number. We've seen this kind of thing before where it's between 0 and 1. 0 would be like the smoothest ice that ever existed. So there's like no friction. And 1 would be the grippiest, it's Gorilla Glue to the 10th power. It's like the minute you're in it, you're never going to move again. So that'll be a coefficient version of 1. It's not quite that bad, to be honest, but because we're still going to stop somewhere. Where'd it go? So, they say this, well, it's 30 mile an hour. So what do you think? This is a little bit evil on their part. It tells you, here we go, in feet. So this will be 30 feet. It would take 30 feet for it to stop. So then the other, it just tells you 0.5. What if it was a little less grippy? Then it should take more distance to stop, right? I like it. In fact, what if I was on the perfect ice, which would mean a coefficient of friction of 0? What do you get when you put 0 in? What's 30 divided by 0?
0.
Undefined. Yeah, you can't divide by 0. So that would be if it was perfectly, like, impossible ice, to be honest. Even the smoothest, coldest ice has some bite to it. You can stop. It'll take a while. But this, if it was perfect ice, you could never stop. Oh, well, all right. This is my life. That's it. Until you hit something, please enter the thing. So part A is just plug and shut. That's all. Just make sure you put the units in there, and they tell you what the units are. Part B would be more interesting. Part B says, what if somebody stopped in 105 feet? 150, sir. What must X have been? So 50 feet was the braking distance. How do you figure out what X is? Well, so is X 150?
No.
150 feet is the braking distance. So where do I put 150? Here. So 150 equals. I mean, and the equations we're looking at, there are two variables. So they could tell me either one they want to, and I can figure out what the other one is. And you see this all the time in these kind of problems. Right, this here, okay, plug it in, plug it in. Now what about this? Well, you just plug the number on that side in place of the other thing that I don't know, the B, the braking distance. I like it. So that's the whole point of an equation with two variables in it. If I know one of them, I should be able to solve for the other one. Right? Unless it's some weird no solution kind of thing. Right? Like here, 0, no solution. Undefined. Alright, how's that? Is that cool? So that is much better than this kind of problem where we have to come up with our own equation. That is where things get gross. That's a true word problem. Okay. So you just got to try those out. Anybody else I skipped over from earlier? Think somebody?
Yeah, 7.6, 49. Go off on the last, very last.
Alright, so this is a good review here. If you haven't done this problem yet, do it right now. This one here, right? 4 over y minus 1. Alright. That looks a lot like that equation we got, but it never finished earlier. Of course, you just hang out. You're like, I already tried it, man.
Well, I'm all the way at the end.
Oh yeah? Okay. I want to see if these guys how far they can get. If you already done this problem, just stare at your favorite wall. By the way, you guys heard, I don't even know the guy, but the guy, Anton, that's the guy who played, Anton Chekov, he played Chekhov on Star Trek.
Oh yeah,
Yeah, 27. Of course, Odd Thomas. I love Odd Thomas. I don't know if any of you guys know Odd Thomas, Dean Koontz books. He was in that movie also. Yeah. Hey, so he's gone. He's dead.
Yeah. You already know what happened, right?
Yeah. So that's what.
Just put it in the parking lot. I guess
What
the
a
car's
way to
yellow,
go.
for rolling back, I guess.
You got the one with the Jeep rollover? The crust? or-
Something. I can't remember what kind of car it was.
That was a Jeep, yeah.
Yeah. What a way to go. Anyway.
Oh yeah.
That's great, Jeff. Just bring everybody down. The thing people forget on this problem, and the problem we had earlier with the 1/30th, was you have to bring the 5 into account also, right? It's down there. So what's this guy missing? Yeah, a 5 and a Y. I like it. This guy's missing.
1 minus 1.
Good. And a 5. And this guy's missing. So now they all have the same bottom. So if you are understanding why this happens, what am I allowed to do here? Why?
Both sides.
Because I got two sides. I have an equation with two sides. So I could multiply both sides by 5y, y minus 1, and so it will cancel. Cool. I like it. Yes, ma'am.
After adding, subtracting, all that whatnot, it becomes 6y cubed. So
No cubes.
squared.
Yeah.
So how?
So we know what to do.
Y and then 6y.
Squared. So whenever you have a variable with the higher power than 1, you get it equal to 0, and then you factor. I like it. Because I like the question. You're like, I can't do it the old way. Well, then you got to do it the new way we developed. So yeah, what do you get here? 20y plus 5y minus 5.
6y squared. Minus 6y.
Like it. Cool. So now I'm going to move everything that way so I can keep my y squared term positive. So I can do, and here I can just put these together. So this is what you guys did? Does it look alright?
Yeah.
I like it. And so what do I do now? Good. Minus 25y. And at the same time I can add 5. So I get 0 equals 6y squared minus 31y plus 5. Those numbers look gross, but you should very quickly realize this is a great thing. When the middle number is off by 1 from the number you're using to find factors, that's awesome. What the hell do I mean? What am I talking about? Well, what do I have to do to factor this?
6 times y.
6